Hi everyone, today we're going to continue talking about limits and differentiation. So let's jump right into it. Now I'm going to talk about that discontinuity. Okay, whenever you have a function, I'm going to show you guys this stuff in here. Okay, so what you have here is that you got a discontinuity right here. Okay, I don't know if it's large enough for everybody to see. But how do you get this graph? Well, this graph right here, the parabola, you're going to get like x cubed minus 1 divided by x minus 1. Okay, now why is this a removable discontinuity? What does that mean? That means that the function's not defined in here, okay, at x equals 1. Why? Because 1 minus 1 in the denominator is going to become 0, right? But you can also see that in the numerator, 1 cubed, it'll be 1 minus 1. It's also going to be 0. So it's indeterminate. Okay, you can determine it, but you can't establish what it is, but it exists. All right, so that's called a removable discontinuity. So the limit exists in here because you can see that the slope is going to be increasing as x goes from left to right. Okay. And it's going to be the same one as x goes from right to left. It's going to be something like, well, something like it's shown here in the, I don't know, in this highlight right here. So you can see that the slope in this point is going to be something like this, like that. I'm just going to get this close. It's going to be something close to this, right? Something like that. You can see that as it goes from left to right and right to left, it's the same one. So that's why the limit exists in there, even though the function is not defined. Now, if you have a function like this, how do you know that it's a removable discontinuity? Well, try to get rid of the denominator, okay? I'm just going to write the function in here. So f of x equals x cubed minus 1 divided by x minus 1. Try to get rid of this stuff because x cannot be 1 in here. If x is 1, then this is going to become 0, and you don't want a 0 in the denominator. Okay? Now, you can see that this thing here is going to be a factor of x cubed minus 1. Why? Because x equals to 1 or x equals 1 is one of the roots of this numerator thing. So when you have x cubed minus 1, okay, equals 0, going to be x cubed equals 1, x equals the cube root or the cubic root of 1, which is just 1. So 1 is one of the roots. 1 is one of the roots, okay, of this thing. So if 1 is one of the roots, then that means that x minus 1 is a factor, okay? It's x minus the root. So how do you do this thing? Well, we try to, you see here, you have x cubed, okay? Now, you can actually make this division. It's called a long division of polynomials. So you can do like plus 0x squared, okay? Plus 0x minus 1 divided by x minus 1. Now, let's start with this thing here. You got x squared. Now, x squared times x equals minus x cubed. So you put a minus x cubed in here. X squared minus 1 equals minus x squared, but you have to switch the sides, so you do plus x squared. Okay? And then you just add these things. You're going to get rid of this. And you're going to be left with x squared. Okay? Plus, well, yeah, that'll be it. Plus 0x minus 1. Now, plug this stuff in here, plus x. So x times x, x squared, it comes over here, minus x squared. And then you have x times minus 1, that's going to be minus x, but you switch the sign, so you put plus x, okay? And you add, so you're going to get rid of this. And you're just going to be left with an x minus 1 in here, okay? And then, well, x minus 1 divided by x minus 1, all you got to do is put a plus 1 in here. So 1 times x minus 1 is going to be x minus 1, but you have to switch the signs. So minus x plus 1, and there you got a 0. So you see, when you divide this thing, okay, this division here actually exists, and it's going to become x squared plus x plus 1. Now, as x approaches 1, x could not approach 1 here, okay, but x can certainly approach 1 here, okay? So as x approaches 1, what's this going to become? It's going to become 1 squared, which is 1, plus 1, plus 1, which is 3. So the limit exists, okay? And that's what you can see in this part right here. The limit exists. As x approaches 1, the limit of f of x is going to be equal to 3, okay? Even though it's not defined in this point right here. Okay. So now I'm just going to try, I'm going to erase all this so we can move on. Got a lot of stuff to see today, a lot of exercises. I mean, this time is the time that I'm doing the numeric exercises, okay? So, let's see here. Just gonna do a bunch of exercises here with you guys so you can, because this is a course, right? It's not about showing the proofs of things anymore. So we gotta get a little bit numerical, not just with letters. So for example, if you have y equals x plus 2. Okay, now as x approaches 3, what's gonna be the limit of this? Pause the video, okay? I'm not gonna say pause the video every time. I'm gonna give you guys some time to solve this, and then I'm gonna solve it. Okay, so all you gotta do is plug the 3 in here. It's gonna be equals 3 plus 2 equals 5. Okay, so this function here, for this function, is f of x, okay? As x approaches 3, the limit of this function here going to be equal to 5, and it's as simple as that, right? Finding limits. Now I'm going to do the same thing. Well, let's get one in here that's a little bit better. For example, y equals x squared minus 4 divided by x minus 2. Well, there's a property in mathematics that when you have some, try to solve this, okay, as x goes to 2, as x approaches 2, what's going to be the limit? Okay, so if you plug the 2 in here, it's just going to become 2 minus 2, which is 0, right? So you can't do that. So you see, you have this thing in mathematics that when you have something like this, a squared minus b squared, is just going to be equal to a plus b times a minus b. And this is exactly what we have up here. So this, you can factor this out, in x plus 2, and that's x minus 2. The whole thing divided by x minus 2. You can cut these two, all right, cancel them out or simplify, and it's just going to be x plus 2. So what is the limit as x goes to 2? Well, you plug the 2 in here, and this is going to be 2 plus 2, which is 4. Same thing works for trigonometric functions. So if you have, for example, what is the limit of sine of x as x approaches pi over 6? All you got to do is plug this stuff in here. Okay, now pi over 6 is going to be 30 degrees. So the limit of this is just going to be half, because the sine of 30 is half. So it's that simple. I'm going to show you guys an example now of a graph where the limit doesn't exist as x goes to 0. See, this is what I was talking about in the previous videos. As x goes to 0 here, you get this infinity thing, and as x goes, well, this is going to be minus infinity, right? And this is, well, okay, we have two things in here. The limit as x goes to 0 from both sides is going to be infinity because it's rising to infinity. Okay, now of course it's not differentiable because it doesn't have a limit in the first place, and as x approaches 0 from the left, the slope goes to positive infinity, and as x approaches 0 from the right, the slope goes to negative infinity. So the limit doesn't exist at 0, okay, of this function 1 divided by x squared. The limit does not exist as x approaches 0. The limit does exist elsewhere. This is another example of a function whose limit doesn't exist as x goes to 0. Okay, sine of 1 divided by x. Why? Because as x approaches 0, this thing is going to start oscillating, and it'll oscillate forever. Now, of course, x cannot be 0 because 1 divided by 0 doesn't exist. Okay, and you can have the sine of something that doesn't exist. But as x approaches 0, this function is just going to start oscillating faster and faster and faster and faster and faster. But it's always going to oscillate from from 1 to 0 to minus 1 to 0 to 1 to 0 to minus 1. You see that it doesn't approach anywhere? You remember the delta and the epsilon? As x approaches a certain c, the f of c, the f of x has to approach a certain limit, and it doesn't approach. X is approaching 0, the 0 is the c, but the f of x is not approaching anything. It oscillates between 1 and minus 1, 1 and minus 1, inclusive, right? 1, 0, minus 1, 0, 1, 0, minus 1, 0, 1. You don't get anywhere, so the limit doesn't exist. Okay. Already explained to you what differential is. Okay, now there's a rule. Okay, I already have this. I'm gonna put this in the video description, a video link that I have in the video description that shows that if y equals x to the n, okay, the derivative of y with respect to x equals nx to the n minus 1. It's one of the first videos that I put in this channel on mathematics, and I already proved that in there. I'm going to put the video link in the video description of this video, and for you guys to see the proof of that, because I'm not going to waste my time showing the proof again. Okay, so with that in mind, we can, for example, find the derivative of y equals x to the fourth. Okay, so what's going to be dy dx? In this case, you bring the 4 down, and then you go x to the 4 minus 1, 3. So it's just going to be 4x cubed. Okay, what if x is to the minus 2? What's going to be the derivative of this? Okay, you bring the minus 2 down, minus 2x, and then it's going to be minus 2 minus 1, that's minus 3. Okay, now if x is 1/5, x to the 1/5, okay, what's going to be this? The derivative of this stuff is going to be 1/5 times x, 1/5 or 1/5 minus 1, because you always got to subtract 1 from the exponent, from the power. 1/5 minus 1 is going to be minus 4/5. Okay, and so this is the derivative of this. Yeah, now I'm going to show you guys. Yeah, I'm going to have to prove a few things in here. Okay. When you have the derivative of f, well, yeah, I'm just going to put this thing here. F of x plus g of x. with respect to dx. What is this going to be? Okay. How do you compute this stuff? Well, what is this? Okay. The differentiation of this stuff is just going to be f of x plus delta x plus g of x plus delta x minus f of x minus g of x, all this over delta x. And it's going to be the limit, right? I'm always forgetting to put this limit here. Limit of all this is delta x goes to 0. Well, all you got to do is to put this thing here and this together. I'm going to do this, okay? I know it's a lot of writing, but I'm going to do them. All you got to do is rearrange this stuff, okay? So it's going to be the limit of f of x plus delta x minus f of x divided by delta x as delta x goes to 0, okay? Oh yeah, and then you can sum limits too, right? Because let's just say that you have, for example, you have a function, all right, that the limit of function f of x as x approaches, for example, 3, doesn't matter, but it can be just, well, let's just put a c then, c. This equals L, okay? And the limit of g of x as x, oh, hold on, I made just one little mistake here. Forget about this delta. So it's going to be the limit of f of x as x approaches c is going to be L. And the limit of g of x as x approaches c, okay, it's going to be the same x approaching the same thing. It's going to be equal r, for example. Well, you see the limit in here exists, the limit in here also exists. So if you're going to add these two limits, okay, it's the same thing as L plus r. So it's going to be the same thing as the limit as x approaches c. You can unite the two limits of f of x plus g of x. It's the same thing, okay, as x goes to c. This thing here is going to go to L, and this thing here is going to go to R, and there you go. So I'm making all this mess in here. Okay. You can just prove, right? So you can unite limits and you can separate limits as long as the variable is the same and it's approaching the same thing. So limit of g x plus delta x minus g of x as delta x, no, divided by delta x as delta x goes to 0. Okay, so this thing here, what is this? It's the derivative of the derivative. I'm going to put this f prime here. Okay, it's going to be the derivative of f plus the derivative of g, and there you go. Okay, so the differential of these two, of f of x plus g of x with respect to x, is just going to be the derivative of f of x plus the derivative of g of x. Okay, now we're going to do some numeric examples here. So, for example, f of x equals 2x minus 3. Okay, what's going to be the derivative of this? Well, you can consider this stuff in here one function like a of x, I don't know, and you can consider this thing here the other function, b of x, okay? So all you got to do is to take the derivative of both of them with respect to x, okay? Now, let's take then the derivative of f of x with respect to x, okay? What's it going to be? Well, you have 2 times x to the 0 here. So all you got to do is multiply this stuff, okay? So you have 2 What's going to be the power here? The power here is 1. So 2 times 1 times x. Now 1 minus 1 is 0. Okay. Minus 3 is the same thing as 3 times x to the 0. Okay. So you have minus 3. I'm just going to put this stuff in parentheses here. Times the coefficient, the power that's coming down, times 0 times x to the minus 1. Okay. Now here you go. What is this going to be like? Well, it's going to be 2 times 1 times x to the 0 is just 2. Minus 3 times 0. Hey, it's 0. Yeah, I know you're multiplying this times x to the minus 1. So it's going to be 0 divided by x. And if x is 0, 2, you're going to get 0 divided by 0 and blah, blah, blah. But forget about this. Why? In this case, you don't want to worry about that. Okay, you just say, you're just multiplying the whole thing by 0 and it's going to be 0, which is 2. Okay, now I just want to prove that the constant, the derivative of any constant is going to be 0. Why? Because let's just say that you got this, okay? And now you have a function here. What is a constant? For example, if you say, oh man, okay. If you say y equals, that was funny, y equals 6. What is this? What does this look like? It looks like a horizontal line, okay? Like this, an infinite horizontal line whose value of y is 6, because in here you see y is going to go 1, 2, 3, 4, 5, 6. So the value of y here is 6 and the function is y equals 6. Now what is the slope of this stuff, of a horizontal thing? It's 0, right? Isn't the slope the rise over the run? So you have delta y divided by delta x. Well, you can pick any y and any x in here. Let's pick this part. Okay, what's going to be the rise in here? How much did x change? Nothing. Didn't change anything. It's 0. How much did y change? 0. How much did x change? Well, let's just say that delta x is not 0, because it's not 0. It's coming from a negative thing here. We can say that this is minus 3, and we can say that this is 7. So 7 minus minus 3 is going to be 7 plus 3, which is 10. So you can say that this is 10, okay, which is 0. So that's why the derivative of any constant is 0. Okay? Okay, let's keep going. Got a few more things in here. Oh yeah, I want to show you guys something. Because, okay, this is the example that I was talking about. Okay. Now, look at this stuff. This function right here is 2x minus 3. Okay. And we just found out that its coefficient, so it's a straight line. And we just found out that its derivative is 2. So that means that slope is always going to be 2 all over. And its slope 2? Yes, it is. It is 2. Okay. It's 2. Why? Well, you're going to have to do the rise over the run. So let's do this in here. Let's just, since it's going to be a straight line, you can just do this. Okay. Now 2x minus 3. Let's just say for x equals 0, y is going to be minus 3. For x equals 1, y is going to be equal to minus 1. Okay. Well, actually, no. For x equals 1, 2 minus 3, yeah, minus 1. Oh, all right. Now, what's going to be the rise over the run? Okay, it's delta x divided by delta y. So minus 3 minus 0 is minus 3. Oh, I'm sorry. I'm sorry, I'm making a big mistake here. So what's going to be the delta y? Well, it'll be the final point minus the initial point. So it's going to be minus 1 minus 3, it's plus 3, divided by 1 minus 0, which is 1. Look at that, 3 minus 1, 2 divided by 1, which is 2. Okay, so the slope is always going to be 2. Okay. Now, let's find the derivative of 2x. Oh, I'm sorry. X squared plus 1. Find it. Okay, so we're going to bring the derivative dy dx. Gonna be, you bring the 2 in here down. It's going to be 2 times x. X what? 2 minus 1, 1. So this thing is just going to be 1 plus the derivative of a constant, which is 0. So it's just going to be 2x. Okay, that is the derivative. Now, what does this look like? Well, since this thing here is x squared plus 1, we know that it's the graph of a parabola because its highest power is 2. Okay, and this is what we're talking about. So you have this stuff in here, okay? And you can see that the slope is always going to be 2x. Now, so that means that the slope is going to change for each value of x, right? Well, right, okay? So it's shown in here, right here, this blue line. When you have x equals minus 1, well, 2 times minus 1 equals minus 2. Okay, so the slope at point minus 1 and 2 is going to be minus 2, and it is minus 2. Look at this stuff. Okay, it's going way down. That means that for each, every time that it goes twice down in y, it goes once in x. So you have something like this. Okay, for this point. Okay, for this point in here. Now let's find another point. For example, let's find that x equals 0. Well, it's going to be 2 times 0, which is 0. Is the slope going to be 0 at x equals 0? Yes, it is. It's this one right here. Look at that. At x equals 0, you got a horizontal line in here, which makes total sense. Okay, and as it keeps going up, the slope starts increasing. Okay, keep going, keep going, keep going, keep going, keep going, keep going. The slope starts increasing. So it's very negative here, right? And it gets all the way down to 0 at the bottom, and it keeps growing. So we're doing fine. Almost over for the day. Okay. Now I'm going to show you another example. Well, this is a course, right, guys? So x cubed plus 2x. Find the derivative. So I'm just going to use this notation, this prime notation. We bring the 3 down times x, 3 minus 1 equals 2 plus 2x. You have a 2. You know, whenever you have something like this, just make this thing disappear. But because this is a course, I'm going to go slow. So 2 times x to the 1, so you bring the 1 down, times x. 1 minus 1 is 0. Okay, so this is going to be 3x squared plus 2 times x to the 0. X to the 0 is 1, so it's just going to be 2. And here's the derivative. Okay, this is the formula of the derivative. Now let's not get too, how can I say, let's not get too tied to variables. Instead of x, let's just go for t this time. Okay, and you want f of t equals 2 divided by t. Find the derivative. Well, So the derivative, I'm just going to put f of t, and I'm going to put a prime here. Okay. So since this is a constant, you can just repeat it. Now what is this thing here? This is equal to 2 times t to the minus 1. You know, yeah, I'm just going to put a minus 1 there. Okay. So it's going to be 2 times, you want to find the derivative. So this minus 1 has to come down. Minus 1 times 2 is minus 2. Okay. T minus 1 minus 1 minus 2. So this is the derivative. It's going to be minus 2 divided by t squared. That's the derivative. Okay. Now we are going to think about this here. Y equals square root of x. Find the derivative. The derivative is going to be, well, this equals x to the half, right? So the derivative with respect to x, of course, in this case, okay, it's going to be 1/2 because you want to bring this thing here down. You want to bring here, right? And it's going to be x half minus 1 minus half, which equals 1 divided by 2 square root of x. Okay. Now, I got a graph here for this stuff, for this example. Okay. So for example, at x equals 1, what's going to be, for x equals 1, what is going to be the derivative? All you're going to do is plug 1 in here. So it's going to be 1 divided by 2, right? You plug 1 in here, 1 divided by 2, square root of 1, which is 1 divided by 2 times 1, which is 1/2. Okay. So the derivative is going to be 1/2. When x equals 4, what is going to be the derivative? I mean, when you say the derivative is always this stuff in here, right? What I'm asking is, what's going to be the angular coefficient or the slope of the tangent at the point x equals 4, right? Because, for example, when you see you have an x, a y, and the tangent value, the derivative. So this is going to be the tangent value. So for x equals 1, what's the square root of 1? 1. And what is going to be the derivative? 1/2. X equals 4. Okay. The square root of 4 is 2. In this case, we're just worried about the positive part. So the square root of 4 equals 2. Okay. And what is going to be the angular coefficient? Well, it's going to be 1/4. Why? All you got to do is plug a 4 in here. Okay. So you have 1 divided by 2 square root of 4, which is 1 divided by 2 times 2, 1 divided by 4. Okay. So we have this little table here. Now, what about when x goes to 0? Well, when x goes to 0, the first thing is this function is not even defined. Okay? Because you're going to have 1 divided by 2 divided by square root of a 0 here. You got to put a 0 here. This is going to be a 0, so this is going to be 1 divided by 0, which doesn't exist. Okay, so when x equals 0, y, it just doesn't exist, man. It's not defined. Okay, it's not defined. So Does the limit exist in there, or well, yeah. For example, what is going to be the angular coefficient of the tangent at the point 0? Okay. Well, you see, x cannot be 0, but x can approach 0, right? So we can find the limit in here of 1 divided by 2 divided by x as x approaches 0. Well, when this number here approaches 0, the square root of something very close to 0 is going to be also very close to 0. So this whole thing, you can say that it gets close to 0. And something like this that gets close to 0 multiplied by 2, the whole thing approaches 0. So this approaches 0 too. Okay? And now you have 1 divided by a very small number that's getting close to 0. So a very small number, I'm just going to put a down arrow here to represent a very small number. A very small number is going to make this thing here approach infinity. Okay? So you can say that as x approaches 0, okay, because it cannot be 0, but as it approaches 0, the angular coefficient or the slope of this function right here at point 0 is going to approach infinity. Okay. Now let's take a look at the graph. Here. Look at this. So at point 4, okay, when x equals 4, and the angular coefficient or the slope is 1/4. That's what we got here. That's what we got here. When x equals 2, when x equals 1, the angular coefficient is going to be half, and that's what we got here. Angular coefficient in this picture is denoted by m. Okay. Now when thing goes to 0, see, in here you got well, let's see, a slope of a tangent that goes kind of like this, right? That's what happens here. And here you can see that the tangent is going up, and it's just going to keep going up in here, and going up in here, and going up in here. As it gets close to this point, look at what's going to happen. Okay, the tangent is going become more and more vertical like this, so it approaches infinity. Okay. For people that don't understand why, okay, let's say this, something almost very, okay, you have this, and then you have something like that, okay? This is like high school math, or even before high school. Well, why is this thing here approaching infinity, the slope of this one approaching negative infinity? Well, because as it comes to the right just this little bit in here, it goes all the way up here. Okay, so it's this huge delta y divided by a very tiny delta x. Okay, so you got a big delta y in here divided by a very small delta x. What is this stuff? This stuff is going to approach infinity. Okay, and the same thing for this stuff in here. As you come with a very tiny delta x, you're coming way down, way down. Okay, so you have a very negative delta y. So we have a very negative delta y, which is huge. Okay, it's a huge negative number. And then you have a tiny positive number. Well, negative divided by positive, this thing is going to approach negative infinity. Okay. Okay, and now let's keep going. Okay, just one more slide, a few more. So this time it'll be x to the 1/3. Find the derivative. So this is going to be x to the minus 2/3 divided by 3. How did I get to this? Well, you get the x 1/3, right? So you make this 1/3 come down here. So it's going to become 1/3 x, and 1/3 minus 1 is going to be minus 2/3. So this is the thing here. This is the formula. Now, what does this mean? Well, you can say that it's 1 divided by 3, okay? And then you're going to have x to the 2/3, because when you have something in the numerator with a negative exponent, as it goes to the denominator, the exponent becomes positive. So it's going to be 1 over 3, and here we go. The cube root of x squared. Okay? This is what this means. This stuff in here is this. Okay. Now, what's going to happen to the slope as it gets close to 0? Well, let's go again. As this thing becomes close to 0, this is going to become close to 0 times 3. The whole denominator is going to be close to 0. And as you have 1 divided by a very tiny number, okay, a number, and this number is going way down, the whole thing here is going to approach a very large positive number. Okay? So you can see that as x approaches 0 from the right, from the positive side, you're going to have a very large slope. Yeah, and then you can think, okay, what about when it approaches 0 from the negative side? Well, it's going to be the same thing. It's going to be a very large slope, because if x is approaching 0 from the negative side, then you have an x like x equals minus 0.000001. Okay? Well, this squared is going to be positive. So the whole sign thing is going to remain the same, and you have a very positive slope, and a slope that approaches infinity. Okay? And do we have that? Yes, we do. I'm going to show you guys the graph. There you go. Okay? So you can see here, as x approaches infinity, approaches 0 from the right or from the left, the slope in here, which is kind of horizontal, right? It's not horizontal, but it's becoming more and more vertical and more vertical, more, until it reaches vertical here. And then from being vertical, it starts going down again, becoming more and more horizontal, and more. It's going to approach 0. It's never going to be 0 up there, but it'll approach 0. So you can see that here, okay, you got a slope that approaches infinity. Yeah, there you go. So the slope of the tangent here, it would be infinity, okay, but you can't have infinity because it approaches infinity. And is that it for today? Yes, that's it for today. See you guys next class.